Applied Mathematics 1, Lesson 1. Introduction to Limit and Continuity. This unit dealing about limits and continuity. Limits are theoretical in nature, but we start with interpretations. Limit can be used to describe how a function behaves as the independent variable approaches a certain value. For example, in the limits of functions such as polynomial, rational, exponential, logarithmic, and trigonometric functions. We can use also to subtract like that, such kind of like this. X minus 2 plus x plus 5 over x minus 2 times x plus 1. X minus 2 must be subtracted because the domain x differs from 2. Now clearly, let's check an example. Here, by the basic value of limits of theorem, limit x approaches to a f of x plus or minus g of x, which is equals to limit x approaches to a f of x plus or minus limit x approaches to a g of x. This is the properties. And the multiplication, you can use it also to determine with it. Limit x approaches to a f times g of x. Limit x approaches to a f of x times limit x approaches to a g of x. And the division, limit x approaches to a f over g of x. Limit x approaches to a f of x divided by limit x approaches to a g of x. So we have determined like this by using the basic value limits of theorem. Let's check about a practical examples. What we use for the practical examples you're going to see here. Limit x approaches to 4. 5x plus 7. Here x, the x is given 4. So put the value of x 4. 5 times 4, 20. 20 plus 7, 27. And the second example is the limits as a polynomial function. If it is undeterminated, you have to rationalize the numerator and the denominator. Limit x approaches to 4, root of x minus 2 over x minus 4. So it must be undeterminate. So let's rationalize the numerator. Root of x minus 2 over x minus 4. Rationalize. Root of x plus 2 over root of x plus 2. Then root of x minus 2 over root of x minus 2 times root of x plus 2. Divide by them. Root of x minus 2 must be cancelled. It's become 1 over root of x plus 2. 1 over root of 4 plus 2. Take out the root 4. 2 plus 2, 1 over 4. We can calculate like this. Practical exercises with limits. Here, the limit x tends to 2 over x minus 1 over x cubed minus 8. Then 2 over x minus 1 over x cubed minus 8, which is equals to 2 minus x over x over x minus 2 times x squared plus 2x plus 4. Factorize them and it will become correct ways. Then minus 1 over x times x squared plus 2x plus 4. X is different from 0 and 2. Then the limit x approaches to 2 minus 1 over x cubed minus 8, which is equal to minus limit x approaches to 2. 1 over x times x squared plus 2x plus 4, which is equal to minus 1 over 24. Now we have substituted about the basic limits of calculations. limits as infinity, let f be a function and l be a real number. This statement can be expressed symbolically by limit x approaches to infinity, f of x which equals to l, such like this. Let me tell you, if the numerator is x squared, if the numerator has the same variables and the denominator has same variables, you have to determine limit x approaches to infinity, 3x squared minus 5x plus 4 over 2x squared plus 4. Here is x squared on the numerator, and there is x squared on the denominator. X squared and x squared, they are the same, so we can take it once. Limit x approaches to infinity, 3x squared minus 5x plus 4 over x squared over 2x squared plus 4 over x squared. Then x squared, because there's the same between numerator and denominator. Then limit x approaches to infinity, 3 minus 5 over x. Here's x divided by 1 must be x plus 4 over x squared. Here x squared. Then limit x approaches to infinity, 2 plus 4 over x squared. Then because the numerator and denominator are the same variables, which like x squared, 3x squared over 2x squared. So 3 minus 0 plus 0 over 2 plus 0, which is equals to 3 over 2. Thanks for listening.